Hi. Apologize in advance for my damn French accent. I try to be a better speaker with time, but obviously it's not right now. So, I'm replacing a colleague, in fact. I'm replacing Stuart Williams, which is a Vert.x committer. Unfortunately, he could not make it today for personal reasons. Anyway, I know Vert.x better than him, so you don't lose a chance. So, like him, I'm a consultant at SpringSource, division of VMware and of advertising. And before going further, I would want to know who has already played with Vert.x. Right, so this talk will be an introduction rather than complicated stuff, so I think we have the right attendees for that. Here we go. Well, you can tweet if you want. What the fuck? Yes, Vert.x is one of the fastest applications framework today. I think it's even faster than some hype stuff like Play framework. But Vert.x is not as complete as Play framework, and we'll see what does it miss and where we will go with the current Vert.x roadmap. So, what is Vert.x? Vert.x is a Node.js as outlined by someone else in a previous talk. It's like Node.js applied to the JVM. It's a polyglot Node.js, so you can write your Node.js program in Java, as well as Groovy, Python, and Ruby, and Groovy, and a lot of bindings are coming. I've heard about Closure, I've heard about Scala, and some stuff like that. Very interesting. I can't wait to see the Closure implementation, to be honest, because I've never understood Closure, so maybe it's time to understand. Well, so aside from the fact it's polyglot, it's also simple. That's what they say. And it's normally scalable, same. But for sure, it's asynchronous. And it's way, I was about to say way too much, but we have. It's never too much asynchronous. So, the current bindings, you can write the application, as I've just said, and Ruby, Python, Groovy, but you can also just write in JavaScript and CoffeeScript because it's based on JavaScript, and then use an AngularJS framework to write your application as well. You can mix also, which is very interesting because sometimes especially for the UI, you don't want to write a server-side template, for instance, and write a separate JavaScript template for the UI. In that case, it might be interesting to mix JavaScript even on server-side with, for instance, Groovy. And even if it's simple, the things you can do with Vert.x can be quite complex. So it doesn't refrain you from doing any kind of web application or even service application. You don't even have to do a web application to use Vert.x. There isn't any configuration files. In fact, this is not very true because there is one. I found it. They hide it, but if you need to play with some clustering option, you will need to tweak one XML for the framework, underlying framework, which is Hazelcast. But we'll see that a bit further after. Why we say Vert.x is scalable? Vert.x is scalable because first, the threading paradigm used by Vert.x is quite interesting. It uses the very well-known selector pattern, which means behind, under the hood, they use a very famous server, which is Netty. And using an I/O pattern for massive concurrent connections is interesting. If you know a bit about selector, you know that a selector is just a loop, a single threaded loop, which selects, depending on the event, the processing to do. So with one thread, you can handle tons of connection because the loop just dispatch everything as soon as they come into the loop, in fact. So you're not blocking any connection, any new connection. You're not blocking any processing. It's just dispatched as soon as it reaches the loop. Well, it tries to. And we'll see that's a very important thing also to consider because if you start doing very long operation in the Vert.x modules, this is maybe not the right pattern for you because blocking operation will block every other operation since a single thread will dispatch everything. But we'll see how Vert.x work around that thing. Another cool thing about the scalability on Vert.x, the more you run Vert.x in a same subnetwork, the more you have instances clustering automatically for you. A bit like Elasticsearch, in fact. If you run two Vert.x in the same machine, automatically you have two Vert.x, and a load balancing is done for you by Vert.x. That's very interesting. About the asynchronous part. So Vert.x offers a certain number of API for asynchronous processing. So the first thing, Vert.x is an I/O framework, and I've just told you about that. The second thing, the handlers. Everything in Vert.x, or nearly everything, except a handler, which is a listener, a callback you can attach to every calls. So like Node.js, you don't block on calls, on method calls, so you need to attach a callback for everything just to be informed, noticed that that the operation has successfully run. So that's an important part of Vert.x as well. Also, the EventBus, which is I think the very core and the primary feature of Vert.x, the EventBus is very interesting. By default, Vert.x provides you a bus, a message bus, where you can publish to a certain address. For instance, you can listen for tweets and publish on the same address tweets with data, for instance, a JSON tweet. So the EventBus is more interesting in Vert.x because when you mix that with all the current features, care about that. That's why the scalability on that. Also, Vert.x runs with APIs for the web, for web socket. You can attach Angular for web socket directly to Vert.x. There is an abstraction of web socket called VS that allows you to don't drag on server-side events or streaming or long-going depending of the browser support. Also, there is a file system API like the other API, in fact, it's still using the callback paradigm and the asynchronous feature. So for instance, if you do an open on file, you need to attach a callback to be noticed that the file has been opened. If you start reading a file, you need to attach a callback to be noticed every line, on every line read. So as you can see, the callback and the handler paradigm is quite used there. And the example. So A Vert.x application can be as simple as that, in fact. This is in JavaScript mode. So you can use the load Vert.x JS, and it will generate for you the required configuration and the binding for the current JavaScript script. So you can call the Vert.x variable and call the few API on the Vert.x. Vert.x, in fact, the Vert.x variable is the center of every API in Vert.x. From Vert.x, you can call create HTTP server, but you can also call create TCP server or a client, or even call the EventBus I've just mentioned. So in that example, the only thing I've done is create HTTP server, which accepts a handler, which will be called every time a request will reach that HTTP server. And this is a very simple test. If the file is index.html, well, we will respond the same file coming from the web root directory. And by the end, to start the server, since it's a kind of fluent API, you can just run the server by calling the listen and the port number. You see there are quite a few bindings, so this is a Ruby one, just more syntactic sugar, quite similar in number of lines. The Python one, a bit more verbose, but not that much. And the most interesting, the Groovy one. And this is quite interesting in Vert.x. Why that? Because every single API needs a handler, and what's better than passing a closure for handler? That's pretty cool, because it's preventing you to write an anonymous class in Java. We won't say the same thing in Java 8, probably, but for the moment, passing a closure is quite more interesting than just passing an anonymous class. Way less verbose. So you see the code, and this is a Java version. So you see there is a little difference, and you see the anonymous class I need to create for that. And well, when you start mixing a lot of handlers, having so much anonymous classes is just impossible to read. So, talking about architecture, the Vert.x has a very strong dependency, Java 7. You can't run a Vert.x application before Java 7. That's a choice made by Tim, the Vert.x leader. Well, he tries to leverage the maximum possibilities from Java to achieve a lot of performances, and Java 7 provides a lot of NIO stuff. Well, Java 7 will be mainstream in a couple of months when Java 6 will be end of life. Anyway, moving on, the second very important dependency, netty. To dispatch and the loop selector is based on netty, and the future version of Vert.x will be based on a strong choice, and Tim and the netty team are working closely together to make the things going well. So moving on, the third dependency, Hazelcast. Hazelcast is a very interesting Java framework to share to share a space of memory between two different JVM, two or more, running on the same subnetwork or on the same machine. So Hazelcast is used by Vert.x to subscribe each server on a specific address, on a specific space in Hazelcast. It's not used as a publish-subscribe mechanism. It's not the protocol used by Vert.x, because Tim Fox has redeveloped his own protocol for that. Well, Tim Fox is like that. Hazelcast is very non-performant, in fact, for publish subscribing. That's why he made the choice to write its own protocol. But at least with Hazelcast, he has a specific address from the other servers, and when he needs to ping a specific server, he gets the address from Hazelcast and then use a TCP client and directly communicate with the server, because he used a TCP protocol with a lot of string and binary and, well, a custom protocol. Anyway, we also have Jackson for the JSON marshalling, gRuby for the Ruby implementation, Gton for the Python, and Reno for JavaScript, and Groovy for Groovy. That doesn't mean was very straightforward, in fact. The key API methods. So the create something server, which can be HTTP, TCP. Same for the client, the counterpart. Vert.x, one of the use cases I've seen was very interesting. I've seen that at GGX, I think, Groovy and JavaScript Exchange, someone used Vert.x for massive concurrent testing on a web application using the create something client, because even as a client, Vert.x performs very well at handling a lot of connections. So generating a lot of traffic can be very useful, very interesting using Vert.x. Also, we have the file system. The shared data, in fact, is an abstraction over Hazelcast. So if you need to share with the other instance something, shared data is a map. You put something inside, and the other instances get an update because there is something new in the map. The EventBus, the periodic, when you need to call something periodic, and the timer, which is a one-shot delay, in fact. So in the server's part, in the HTTP part in particular, we have the route matcher, which allows you to do something very similar to URL mapping in Grails. There is the server WebSocket, which allows you to host and react on server on WebSocket connections. And you have also the SockJS server, which is the abstraction, and I highly recommend to use that over the server WebSocket, which is quite low level. Same for the client. Interesting thing, you can notice that we have also an HTTP client for WebSocket and SockJS socket, which is quite interesting for testing. Same thing than the client in TCP or HTTP. But I find that very often very difficult to test WebSocket sites and WebSocket connections because we don't have anything in Java very well. There is something from Atmosphere framework, but at the very least, Vert.x comes with something. So if you need to test your own Vert.x WebSocket connection, you have something to test that with the SockJS or the WebSocket client. Also, moving on the EventBus. So you see the simple form of this EventBus. If you need to send something, and if you need to get a response from that, you have EventBus.send. I've removed the Vert.x prefix part. Normally you should do Vert.x.EventBus, but you can assign that in your script to something else and just use EventBus. So the send method uses a reply handler because whenever the address handler has something to reply, they can use a reply address, and when they send a message to the reply address, the reply handler will react. And you can even achieve bidirectional communication if the reply handler have to reply something again to the address. They can just use the reply either to. So send is for reply request reply pattern. Publish is for publish subscribe pattern, which is everyone will receive. Very important part. Sorry for that. I've missed something about send. Only one instance of the handler will receive something. If you have multiple instances and they have all deployed the same handler on address, only one will receive the message. Unlike the publish will publish to every handler listening on that address. But because it's one-to-N publishing, they don't have a support for aggregating response, so you don't have a reply handler. You could do that yourself by sending in the reply in the address handler. You can send again a message at the very end of your processing, but Vert.x doesn't come with that support by default. Anyway, very interesting part, the EventBus bridge, which means you can even use Vert.x from the JavaScript perspective. So in JavaScript, you can declare a Vert.x in UI, in your Angular.js UI, for instance, and send on the same topic used by the server. You will have to whitelist this address to be authorized to accept messages from the client. But other than that, it's pretty straightforward. So, I've already talked about Hazelcast, but something very interesting on Hazelcast. Sometimes, unfortunately, message brokers and messaging frameworks don't secure the message protocol between the client and the broker, or the client and the server. One cool thing about Vert.x is you can secure that with SSL if you need to. So if you have multiple instances on your cluster, they can communicate in a safe way. That's very interesting. Yeah, at least in the enterprise world. So, Vert.x has two kinds of artifacts. We have verticals and we have modules. So, a vertical is the unit application artifact. If you need to run something in Vert.x, you need the command line Vert.x and run, and you need to reference a vertical for that. So this is the main application. You can deploy as much verticals as you want. You're not limited to the vertical. You can scale your vertical using more thread. For instance, if you need to parallelize one vertical because, for instance, your handler listening for a new WebSocket connection may need more thread than one thread accessing at one time the vertical handler. Well, in that case, you can scale to multiple threads. Other than that, we have modules, which in fact are the similar things we find in Grace. This is the Vert.x plugin. So you can combine modules. You can use modules to add a framework, to add something, for instance, Spring, for instance, MongoDB connector, or something like that. And unlike Grace, the way you communicate with modules is quite different. You can't access the API directly. Between each component, the only way to communicate is the EventBus. You can't never use directly a method call between modules. Why that? Because Vert.x has made a choice. They don't share the class loader. So each of these modules have different class loader, and they are strongly separated, isolated. You need to communicate through an EventBus to do something, which is quite interesting because, for instance, something we can't do at the moment in Grace, but you can do that with Vert.x. You can hot deploy a plugin because you need just to add a Vert.x instance a vertical instance or a module instance to your current running architecture, they will auto-cluster. And you will, Hazelcast will be informed that a new participant has joined the cluster, and it will be informed by all the new address it listens for. So whenever you publish to that address now, there is something to listen for, the new module you've deployed. It works. You don't have to restart the server or something like that. Because you can't do everything in a very short lapse of time, there is a special kind of vertical. You can deploy a vertical as a worker, because by default, as I've said, verticals will use the selector and be dispatched with a selector, a mono-threaded selector. But since it will block until the processing of the current vertical has been performed, this is quite counter-performant. If you need to do long-running operation, for instance, calling a JDBC database, you need to declare your vertical as a worker vertical. And that way, it will use a different paradigm. It will just use, in fact, a thread pool, 20 by default, and pick up on that thread pool and dispatch the operation on that thread pool, and maybe blocks a caller if the thread pool is completely busy. So, for instance, if I need to write a Vert.x application, I can just create a Vert.x.js, write the application always in JS, in fact, always using the Vert.x import. If I need to deploy, I can use a Vert.x deploy module, because a module can deploy other module. And this is quite interesting if, for instance, you need to bootstrap an application. You have a main vertical, and this application will deploy other vertical, a bit like deploying other plugins. The application is the only one you will be running, in fact, because it will be able to run the whole architecture by deploying the other module. You are calling deploy module in the main. So you can pass config to the module. In fact, it's a hash map configuration. And for the moment, the official modules are, in fact, not that much, but the community is growing quite fast. So we have the authentication manager, the form upload, JDBC persister, the mailer, the Mongo persister, the session manager, the web server, the work queue. That one is very interesting, because if you call an event, if you use EventBus to send an event, if something happens and every server crash, your message will be lost. If you need to store your message into some database, I think work queue is still using MongoDB. This is the module you have to use if you want some high availability and be sure that a message will not be forgiven if something crashes somewhere. So work queue is quite interesting for that. Oops, sorry. The module web server allows you to do some stuff, for instance, enabling the SSL connection, also serve some files using the web root. Well, I won't spend a lot of time on that example. Also, if you need to create a plugin, it's quite simple. You don't have to write a Groovy descriptor of your plugin. In fact, the descriptor is in JSON. You have to write a mod.json. If the module needs to declare a main, you can declare it using the main key. If it's a worker, you can declare it as a worker. And if it needs to include other plugins by transitivity, you can also declare them there. The difference between something with and without a main is simple. If you need to add a library, a Spring library to a module, for instance, includes will in fact merge a class loader from this module. So if this module adds Spring, for instance, this module will have access to Spring. This one doesn't need to declare main, it's just there to import a new library. Well, as I quickly said, the best practice around Vert.x is, in fact, if I should retain one, this is that one. Never block the event loop. Never do long stuff on the event loop. So, I have few minutes to demo a bit, but moving on, I think I'm going to just finish on the roadmap for the slide. Coming in the next week, next month, normally rather, I think it's rather next week. So coming soon, the lazy installation, you don't have to download a Vert.x installation, a bit like Gradle script and Gradle U. Language as module, for the moment it's impossible to package new languages as module, but this will come. New languages support, Scala and Clojure. And also a very interesting plugin, a very interesting module, sorry, a management console, which allows you to monitor your Vert.x cluster directly from the web, in fact. A very interesting one. If you have to try Vert.x, I strongly recommend that one because the UI is quite neat, and you see exactly what's happening on your current cluster, so that's very interesting. Well, the Vert.x team is currently working with the Eclipse team to get some compatibility support. I don't know about IntelliJ, to be honest. The build config also will be probably a simple way to create artifacts or set of application. Easier testing, because testing is not that easy with an asynchronous framework, and more example. So, Vert.x is an open source project, apparently moving to Eclipse Foundation. So feel free to participate, to read the mailing list, accept the drama. That's a very, very interesting community, very dynamic one. So I strongly suggest to have a look. It's a quite young framework, so if you want to shape the future of the framework, it's the moment to go there. That's for the links, Vert.x.io, and the two official developers, Tim Fox and Pete Starr, Stuart Williams. Time for a quick demo. Wow, I've managed to crush IntelliJ. Interesting. No worries. Waiting for that one. Any questions so far? In the meantime, my nice IDE is loading. No? All right, it's coming. So this is a very simple example. Script, vertical script in Groovy. So because it's Groovy, we don't have to create a class to embed the script. We don't have to create a main. And we don't have to extend a superclass unlike Java, which forces you to extend a class to get the vertex variable. In Groovy, it's just a binding variable, and you access it like that. If you need to have an access to the EventBus, just assign that to some variable. If you need to create a web server, just create it using an hash map configuration. See that I've allowed to bridge the event from the server to the client, but I didn't specify any events, any topics, so nothing will go to the client there. Then you have also access in Groovy script to a container variable, container binding variable, which allows you to deploy a module. So, for instance, we'll create a module, a web server module, to host, in fact, our application. We pass the configuration we have defined. The number there is the number of vertical we want to deploy. We can deploy 1 or we can deploy 10. It depends on the concurrent load you will have. And the most interesting part is the last argument, which is a closure, because deploy model is asynchronous. When you execute that code, it's still running after that. If you will do a println after deploy module, you will have that immediately, even if the module is not yet deployed. Like everything in Vert.x, this is non-blocking. So to do something whenever this module is deployed, I use a closure, the callback, and in that closure, I declare that in the EventBus, I will register an address called Vert.x.tweet, so everyone can send a message to that address. And I define this handler with a closure. Imagine that with Java anonymous classes. This is quite terrific. And in that handler, I just declare a println tweet, the body of the message, and tweet, because I expect that message to be a JSON message, and I can just pass the nested nodes like that. So this is to listen on an address Vert.x tweets and to println something whenever it receives something in that address. This example also uses the Spring integration DSL. Spring integration is an abstraction over over the enterprise integration pattern. I won't go further than that. Tomorrow I will explain Spring integration a bit further with the EventBus and the EventSI plugins on Grace. But Spring integration allows you to create channel of communication and consume from any sources, a bit like Camel, if you know Camel. You can consume from Twitter, for instance, and that's the thing I will do, in fact, in that instance. So I create a builder coming from the Spring integration DSL project. This builder has a method called do with Spring integration, and inside that it's a builder, so you expect some DSL stuff. The first thing I will do, there is declaring a RabbitMQ server. RabbitMQ is a message broker. This is just as a matter of example. If you need to communicate to a message broker to do anything else, this is quite simple to do with the Spring integration DSL. So I've just declared with Rabbit a RabbitMQ connection. Not detailing that much. The only thing I detail is in that RabbitMQ server there will be a queue called tweet where I can consume and there will be an exchange called Twitter when I can send message. That's the only thing I need to know about that message broker. We don't need to go further with RabbitMQ yet. Then I will use a Spring integration project called module called int Twitter. In fact, it references namespace. If you know a bit of Spring configuration, this is corresponding to namespace blah 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 in Twitter. And by default, it uses a convention to autocomplete the URL. This is just to show the support for methods that are not handling yet some module of Spring integration, because Spring integration is a big project, and sometimes you need to be back to the Spring XML configuration to use it. This module allows me to use that tag, that namespace, plus the tag search inbound channel adapter, which in fact consume from twitter.com everything, and you need to pass some arguments, and in fact the mandatory argument is there. You need to consume, you need to do a query. So I will consume from everything that has a Greach message, Greach hashtag. So that's it. And whenever something happens, I dispatch that to a channel called tweets_in. The channel, the mean of communication in Spring integration is there. So every time something is posted on that hashtag, on this polling rate, you can configure that if you want on a polling fashion, or you can do that on an event-driven fashion. It depends on what you want. But in that case, I want every second to reach twitter.com and display the new tweet. So every tweet will go to channel tweets_in. This channel is used by this component called transformer. In fact, in Groovy DSL, it's just a matter of using transform. You define the channel in input, so it's tweets_in, and in output you want to call a channel called tweet_text. And you want to do something. It's a transformer, so you can just, using a closure, take a payload and return a new payload. In fact, in that case, I'm just extracting from the payload, the message body, a text. Okay, so everything coming to that channel is sent back to tweet_text channel. You see, you can do very complicated flows. It's a very complete example of what you can do. Since I'm sending something to tweet_text channel, so that channel, I'm using that somewhere. I think took there tweet_text. So whenever I use tweet_text channel, it will call the RabbitMQ connection using the MQP send, and send on the exchange name called Twitter I've declared before. And the last thing I need to declare is a listener, because I sent to RabbitMQ, I need to listen something. I didn't send directly to that listener. So this is the purpose of MQP listen. I'm just listening for tweets, the queue tweets I've declared on the due with RabbitMQ. And whenever I do something, whenever the request channel is not required there. Anyway, whenever I listen for something, because the next element there is handle, and it's declared inside the message flow DSL, they just chain, in fact. So each component chain, and the next one is handle, and the handle is just a matter of invoking anything you want. And in that case, I go back to Vert.x by calling the EventBus.publish Vert.x.tweets with the map tweet column IT. That means if we go back to the initial declaration, I will go there, and that's why the message body has a tweet key, because I sent just a hash map, which will be converted. So if I run that before being kicked from there, one of the latest thing Stuart has added to the project is the Vert.x annotation to test run the class. So there are JUnit annotation to test your Vert.x application, which are quite interesting because it's a pain, to be honest, to test without that. Just launching the test. So the test will use the B4, do a sleep of 100 milliseconds to allow asynchronous framework to initialize, because everything is asynchronous. You need to wait a bit, not that much, to give the hand to Vert.x to initialize. This is quite, this sounds like a hack, to be honest. The test there has an annotation called test vertical. You declare where the name of the vertical and where it can find it. So it directly uses a Groovy script. No need to compile it before using it. And this is very dirty because it could just launch and then shut down the test. I'm just blocking until I do I force a shutdown. That's why I use a command latch. I could have used system.in to block on the input, but unfortunately some IDE don't support that when you do run test. So this is a test running. See, the println is working. I wonder who tweeted last. But it's almost beer time, hurry up, is quite true. And I think I'm done. So just going back to the last slide. Any preguntas? In fact, I'm ashamed because my mother is Spanish and I don't talk a word in Spanish, and she's even a Spanish teacher in France. So I'm very I'm the shame of my family. Anyway, moving on. Any questions? No? Muchas gracias.